Today we are going to be solving equations with variables on both sides involving some parentheses as well. So let's take a look at our first problem here. And our first one has a 5, and then we're multiplying by a -1. Now if you see a minus sign right before the parenthesis, and there's no number in between the minus sign and the parenthesis, think of it as like a -1, or think of it as the opposite of this expression inside the parenthesis. Well, if you distribute that negative, we're left with just a -n and a +4, and now we have no more parentheses there. It's the same thing as distributing the 3 over the n plus 2, however, it was just a -1 instead. So that leaves us with a 3n plus 6, and now we're ready to combine some like terms on the left-hand side of that equation. So we add those two numbers together, and that gives us a 9 minus n equals 3n plus 6. So from that point, we're just going to do some opposite operations. I'm going to add n to all sides, and I'm going to subtract the 6 from all sides as well. So when I do that, I'm left with a 3 equals 4n. Well, just one more step there. I'm going to divide by 4, and we'll have our answer. Answer's a fraction, and that's okay. It happens time to time. So 3/4 is what we have for n. Let's take a look at our next one. Same sort of thing here. When you see the minus sign right in front of the parenthesis, this means that we're taking the opposite of those two terms inside the parenthesis. So what's left over is a 5 minus an x plus a 3. On this side, this time we're distributing a 2 over that subtraction. Don't add first, because order of operations says you multiply first. So we bring down our -1, we have a +2x and a -6. So now we go ahead and collect some like terms. We've got a 5, 3 to collect there. Over here we have a -1 and a -6. So on the left-hand side, they're the same sign, so we're adding, so that gives me 8 minus x. On the right side, they're the same sign again, so we add once more, but the sign stays the same, so -7 plus 2x. And then we could go ahead and move terms around. So I'll add the 7 to all sides, and I'll add this x to all sides. And so what's left is a 15 equals 3x. So from this point, divide by the 3, and we'll have our answer. So there it is. So we have 5 as the value of x. Let's take a look at our next one. We got a fraction, and if you don't want to deal with the fraction, let's get rid of it. So if we do that, notice that the 1/3 is being multiplied by this expression. So if I was to get rid of a 3, a 9, and a 9, I'm going to multiply the entire equation by 9. Every number by 9. Now, this is all one number because 1/3 is being multiplied by this number, x plus 1, which is one number. So all I have to do is distribute the 9 to this 1/3. So this makes 3 here. Multiply each of these numbers by 9 as well, so those 9's cancel out. And this 9 as well will cancel. So what I'm left with is a 3 multiplied by x plus 1. 3 because that's what was left over when I divided 3 into 9. And on this side, I've got 2x plus 7. So now I've got an easier equation to deal with. So now I'm going to distribute that 3 over this term. Leaves me with a 3x plus 3 equals 2x plus 7. So just couple more steps actually here. We've got to subtract the 2x from all sides, and subtract the 3 from both sides. And I get my answer right there. X is 4. The next two problems are different scenarios, so we don't end up with numbers like we did on these, so we'll see what happens on these problems. The first step is the same as before. Distribute, so we have 6x minus 3, and bring down the 5. Over here we distribute, and you see how it equals 6x plus 6. So we go ahead and do a little more work, combine some like terms here, combine the -3 and the +5, and that gives us a 6x plus 2 equals a 6x plus 6. Well, at this stage, you can see what the answer is going to be if you had a little bit more understanding of these problems. But we'll see it once we move the x's over. Notice that when I subtract 6x, I'm not getting x. I'm getting 0. Those cancel out. So I'm left with 2 equals 6. Does 2 equal 6? no. So that means this is a no solution. There's no possible value I could put in for x to make an answer. So this is a situation when all the x's canceled. Notice how the x's here canceled and the x's here canceled. When they all canceled and I had two different numbers, that's no solution. The next one's a little bit different, so let's see. Combine some like terms first. We have 3c plus 7. On this side, combine the like terms, and I have equals 3c plus 7. Well, when I go ahead and subtract the 3c from both sides, I end up with a different scenario. Well, again, I'm getting the c's to all cancel. These c's are canceling, these c's are canceling as well, but this time I end up with 7 equals 7. Or, if I had gone further, I would have ended up with 0 equals 0. When the two numbers are the same, so we have the same numbers equal, that's when we have all real numbers as a solution. And so all real numbers mean every single number, any number could go inside for C in this case, and we get a true solution. So those are the differences. When all the variables cancel, your answer is either going to have two numbers that do not equal, which is no solution, or two numbers that do equal, which is all real numbers, are solutions. Let's take a look at this word problem here. The long distance rates of two phone companies are 36 cents per, plus 3 cents per minute for company A. Alright, that's company A. Now, 36 cents plus 3 cents per minute. So per minute, this is when we have our variable cost. So when you see the word per or each, that tells us that we've got a variable amount here. Depends on the number of minutes. So company A, let's write down company A. Their charge is this 36 cents plus, and then we had the 0.03 cents per minute. We don't know the number of minutes, so we're going to use M for the number of minutes. And then it says, and company B, and well, 6 cents per minute for company B. So they just charge 6 cents per minute. They don't charge an extra amount. So company B charges just 6 cents per minute, but no extra amount like the company A charged that 36 cents. How long would a call that costs the same amount no matter which company is used? How long? How long is number of minutes? So that's what they're trying to solve for. So that's why we used our variable M. That's what we want to come up with. Now same means that we're going to set this equal to each other. So that's what we're going to do here. Now I've got some decimals, so let's go ahead and get rid of those. I'm going to multiply this whole equation by 100. And when I do that, I'm now left with 36 plus 3m equals 6m. Now I don't have any decimals to deal with. I wanted to move those decimals 2 spaces to the right. So now I'm going to go ahead and subtract the 3m from both sides. And that leaves me with this 36 equals 3m. And so from that point, all I have to do is divide by this 3. And 3 goes into 36 12 times, so 12 minutes. In 12 minutes they will charge the same. What will that cost be? Well, here we're just going to substitute. Take that 12 and put it back into either one of those two m's, whichever seems easier. I'm going to use company B because that seems a little bit easier. So I have 0.06 times by 12 minutes. So I multiply, 6 times 12 makes 72, but then I got to move the decimal back 2 spaces. So back 2 spaces puts it right there. So 72 cents, and that's the amount that the cost will be when they're the same. So after 12 minutes, they're the same. 72 cents is the cost. Now notice that company A is more expensive to start with, but company B is more expensive after the 12 minutes. So before 12 minutes, we'd go with company B if we wanted the less expensive one. After 12 minutes, you'd go with company A because they will be less expensive because their amount, their variable amount, their changing amount is less than company B. Those are the problems you'll see on tonight's homework. Good luck.